All right, so just to introduce ourselves, my name is Xavier Léauté, and so I work as a software engineer at Confluent, and here's my incredible partner, Gwen, who some of you already probably know from other meetups and books and talks. So with no further ado, what we want to do today is talk about how we think about monitoring Kafka, and instead of just going through a long-winded talk about all the possible metrics, we kind of wanted to share some of the real-world experiences that we've experienced with clients, and kind of talk over that and use that to kind of see how we can go about monitoring. So I think we can skip over the slides since almost everyone already knows about Kafka. Just to recap, distributed, scalable, fault-tolerant log with lots of cool guarantees. So typically when we talk to people about Kafka monitoring, this is how they think about it. They feel overwhelmed with metrics, and they imagine it's going to be a really crazy thing to monitor. But in reality, when we actually talk and sit down with our clients, what happens is that it feels more like we're in a snowstorm and we have no visibility at all. There's basically, we have no metrics to look at. We basically have to go through and kind of dig everything out together with our clients because they don't have anything set up in the first place. So we're going to talk about three experiences today. The first one is talking a bit more about the broker side and kind of what happens during upgrade when things don't go as right as we expect. Then I'm going to, and that's going to be Gwen talking about this. Then I'm going to be talking more about the client side and how you kind of go about figuring out what's going on with a troublesome Kafka application. And the last one would be about kind of the in-between, talk a bit about replication and go a bit more detail of the how you go about doing that. So with no further ado, I'll leave it to Gwen for the first part.
OK, so in general, upgrading Apache Kafka is fairly easy. And there's also a bunch of documentation telling you how to do it step by step. It doesn't require a lot of magic. And yet we get quite a few support calls that basically says, we upgraded Apache Kafka from this version to that version. These versions are quite random. We get it from any two sets of versions that you can think of. We get the same thing. And we did the upgrade, we restarted, and now something is really wrong with the broker. And you think that this level of detail will not allow anyone to debug anything. And yet this is a quote. That's copy-paste from a customer ticket. People usually look at the cluster and they only know that something is wrong. And it's our job to help them figure out what. So we come up with a checklist. If you've ever interacted with any competent support organization, which I admit, it's not as common as it should be, they basically start asking you for a lot of data. Please give me this log. Please give me that log. If you monitor anything, I need to see those bunch of metrics. So let me kind of go through all of them one by one and kind of explain to you what we see when we get this information. So in the upgrade case, the first thing we look at, and in general, whenever we suspect that there may be errors in the log, an unhealthy cluster typically will have something, the first thing we look at is in the log. And in this case, we basically, stack dumps tend to stand out in the log. So we pay our attention to stack dumps that happen in the correct time frame. And the first thing we see here is that, oops, Java ran out of memory. That pretty much explains everything, right? Kafka without memory is not going to have expected behavior. If you are a bit better and you know more about Kafka, you'll even notice exactly what is causing those issues and where exactly Kafka is running out of memory. But you can get quite far just by knowing, OK, I ran out of memory. So we ran out of memory. What is our prime suspect? Garbage collection. Kafka should have a garbage collection log, and our competent support team will totally ask you for the garbage collection log. I'm not amazing at actually reading the raw log. Thanks God, there is something called gceasy.io that allows you to update the log and get a very nice report. And you look for full GCs, time spent doing GCs. In this case, there are no full GCs, but you can see the biggest pause is a very high number. 3-second garbage collection pause is suspicious for two reasons. One, it's very long. It's the time that the entire application is frozen, waiting for Java garbage collection. But more important, 3 seconds exactly is the timeout for communication between Kafka and Zookeeper. Kafka absolutely depends on Zookeeper to maintain liveliness and cluster cohesiveness. So if this basically means that we are going to see somewhere in the log a lot of Zookeeper disconnects, which means that the broker will appear dead to the rest of the cluster after 3 seconds or so. So, OK, that was already good information, but we also want to check what's up with the rest of Kafka. You have a lot of ways to collect metrics. We like Confluent Control Center because we wrote it in a way that works very well for us. The things that you want to watch out for are, first of all, under-replicated partitions. Kafka is a replication machine. You write events to one broker, and in order for the data to be available, it gets replicated to other brokers. Pretty much any problem in Kafka whatsoever will show up in under-replicated partitions. So basically, it doesn't tell you what the problem is, but whenever the number is above 0, you know that there is a problem. And if it's 0, then usually Kafka is OK. I can't imagine any problem that will actually leave replication working as is, like on the broker side. So this can mean a lot of things, but in our case, we know the cluster is unhealthy. Other stuff we want to look at is the pool usage. Basically, Kafka has 2 big thread pools for handling produce and consume requests. If you run out of threads, it basically means that there will be queuing and requests will not be processed in time, and you're going to see high latency. That's the last thing to look at. What is the latency for requests for the users? That will also tell you user impact. That's usually when people complain, right? I sent an event to Kafka, and it took me 1 second or 3 seconds or however long to get an event to Kafka. So those are the 3 big things that we normally keep an eye on. Just watching the metric itself is not quite enough. You want to check the history. So pretty much all of them you can see history. Make sure that you keep whatever monitoring tool you use, keep sufficient history. So if I ask you, I see your request pool is at 53%. Is that normal for your cluster, or is that something that started at the time of the incident? You should be able to reply to this question. If I tell you, how often is the under-replicated partition? Is it steady under-replicated, or is it something that keeps dying and then coming back, and then something happens and then it comes back? You need to be able to tell me about those patterns. And the last thing you want to have, Kafka has the metrics for not just the total latency for request, but a breakdown. So if you look at what request does inside Kafka, you send it over the network, and network thread picks it up, puts it in a queue, and iOS thread picks it up, either writes it to the local disk or pretends to, and then it also gets sent to a bunch of other brokers. We wait for a response from the other brokers saying, hey, I got this message, and then we send a response back to the client. All those things are timed. How long did you spend writing to the local disk? How long did you spend sending something over the network? If you see what takes the most time, it gives you a huge hint. Oh, it's a network issue. Oh, it's an I/O issue. Oh, we ran out of CPU. You can kind of tell what's going on. So it's very important that you will have this kind of request breakdown. So not all of our clients are using a control center, but we still need information. In this case, these are the real logs that arrived with the big upgrade issue. First thing we saw, ISR shrink and expand basically means that the partition becomes under-replicated and replicated again and under-replicated. Replicas fall out of sync with the leaders. They fall behind because replication is not working, and then they come back. So we saw a lot of that. And in this case, it's obviously because the broker would lose connectivity to Zookeeper and come back, and therefore things would just come back. The list of replicas would go shrink and expand when that happens. The other thing we saw when we were looking at the network pool usage, how many network threads and how busy they are, we saw that during the incident, it was pretty much pinned at 60%. And pinned at 60% means that there is one thread. We have 3 network threads by default in Kafka. It means that one of them is absolutely pinned on something. It's basically blocked. And the question is, what the hell is blocking it? So now we collected, from all those metrics, we collected a bunch of clues. But you really need to understand Kafka to put it together into one big picture. So this is the one big picture we're missing. Basically, Kafka messages have a version. And when you upgrade a broker, you can choose whether to upgrade the version of the messages that the broker writes to disk, or if you can also leave the broker at the previous version. In this case, the default, if you just do an upgrade and not read any of the docs, it will upgrade the broker to 1.0 and the message format to 1.0. And if you also upgraded your producers and consumers, then the data flow path will be what Kafka normally does. You'll get an event from the network. It will pretend to write it to disk, but it actually goes through the Linux page cache. No, that's the magic Kafka zero copy optimization. From the Linux page cache, consumers can read it directly, meaning it goes to memory, to network, memory, network, without doing a lot of I/O, without waiting for disk, without going through JVM. Everything is perfect. The problem starts when you also have a consumer that actually expects older version of messages, messages from version 0.9. Because that means that you have to convert the message that the broker actually has, which is 1.0, to 0.9. And to do that, we have to take the message in memory, copy it from the page cache to the JVM heap, do a conversion and send. We lost the zero copy. We're starting to use the JVM in ways that previously Kafka did not use. And that pretty much explains everything that happened. Another way you can find out what happened if you dump the JVM heap, and you'll see all those converted messages that in normal life don't appear there. So now it explains everything, right? The network thread is super busy because this conversion is basically done in a blocking way. Used to be done, we fixed it. In a blocking way, in the network thread, it kind of like explains everything that was going on. The JVM heap was dirty, we ran out of memory, nothing was tuned for this scenario. The thing that took me about 5 minutes to explain to you, and I think all of you more or less got what happened. What made it take so long is that we talked to the customer and we said, okay, we need a GC logs and we need metrics. And they're like, GC logs, metrics, interesting. What does that even mean? How do we get those? And then they're like, it's too much work to figure it out. Let me change some configuration, bounce the brokers a bunch of time, and maybe it will get better. Spoiler alert, it never gets better. Changing random configuration and bouncing brokers a few times never really resolved anything. Actually, bouncing brokers in itself, it's kind of heavy operation. It causes a lot of leader election. Rebooting brokers doesn't usually solve issues. So this is like what the most newbies do and what we really, really hate in support, because it takes a lot of time to figure out what happens because we need to teach them how to collect logs. What we really want competent users to do is to know that Kafka writes logs, and they exist. And Kafka writes logs by default at info level. Keep them that way. Don't say, oh, it uses a lot of disk space and Splunk is expensive, we'll set it to error. You will not have enough information at that log level. Linux throws stack traces. You're all Java engineers. You should be competently able to read the stack traces and at the very least say, oh, Kafka ran out of memory. Here's the out-of-memory error. A lot of our users that think Kafka is magic and mysterious don't think about it as just a Java app, and they're just afraid of even trying to read the log. You understand a lot if you just try to read the log yourself. Collect metrics. We like Control Center, but I don't actually care what you use. Find a way that collects metrics. And again, don't tell me, oh, there's too many metrics, and Kafka is, and it's too expensive for me to collect all of them, so I'll only collect 5 metrics, and I'll only store them for 30 minutes. Don't do it. Store them for a longer amount of times. Even if you have to aggregate them, we need to see patterns. You need to be able to tell me what is normal. And Kafka documentation has a long list of what to monitor. Don't bargain. Monitor all of them. Trust us. They're all there for a reason. We keep adding metrics after every incident. We need it to get a visibility into what's going on. And then if you want to be even better, you have to monitor clients. Xavier will talk a lot about that. You can configure Kafka to do heap dumps when it runs out of memory. That helps us a lot, although we don't expect everyone to do it. Use GC Easy to understand the garbage collection log. It changed my life. So many Kafka problems are actually garbage collection problems. And then before you start changing random parameters and bouncing a bunch of stuff, maybe call your favorite support team and tell them what happened. It helps us if we don't have to first diagnose all the mess that someone caused and then diagnose the original issue, and we can just focus on one issue. If you're a really pro, that was my first instinct. Pros read the docs and don't get themselves into the mess in the first place. But apparently that doesn't help. Even if you did a successful upgrade, someone can just connect an old consumer and start causing this mess at any given point in time. And you may or may not have control over what people in your organization actually do. So you really want to be kind of aware. Everything I told you, like, oh, Kafka only has 3 threads, so I immediately knew that this is something is pinned and blocked because I saw this specific number. You may be able to analyze the heap dump yourself. You may be able to search the Kafka Jira for specific bugs, like copy the stack trace and see if everyone else ran into it, and kind of check if the metrics make sense. A lot of times it's like, what does 60% mean? What does it mean when things go in and out of ISR? This kind of thing. If you're really, really, really a super pro, you can even find proposals to Kafka that are related to your issue, like people saying, we'll add metrics, or maybe you can even open a proposal yourself and suggest, hey, it was really hard for me to troubleshoot this. Why don't we add a new metric that will make it a lot easier? So that's kind of the range. You don't have to be like a super pro, but you definitely have to know how to collect metrics and find logs, and especially the garbage collection logs on the broker. And now to the client side.
All right, so on my end, I'm going to talk about what happens if your app just stops working. You just don't really notice, like something's happening, something's wrong. What do we start looking at? So same here, we have a checklist of all the things we kind of want from people to send us, things they want to look at. And the most important thing is really starting with the consumer lag. So what is a consumer lag? I mean, similar to on the replicated partitions on the broker side, on the client side, knowing the consumer lag is not zero will tell you that something is wrong, or at least if it's like different from like your usual consumer lag. It won't tell you what the problem is, but with some context, you can figure out what it is, and that's really like the root of, it helps you identify the root cause from the issues. So the first example I'm going to talk about is an app that we've been running in-house and trying to debug, see what's going on. So the first thing you want to look at is the lag in your described consumer group's output. So having 40,000 messages lag per se is not necessarily a problem. I mean, if you're running 300,000 messages per second, I mean, 40,000 is not really that big of a deal. So that's not really what you want to focus on in the first place. What you really want to focus on is really the imbalance across the different partitions. So in this case, we see that we have like 2 partitions that are lagging by almost like 2 orders of magnitude more than the other ones. And we need to figure out why. So if you look a bit closer, we have 4 partitions. We have on the consumer ID, we have only 3 consumer IDs in this particular consumer group. And it turns out that the third consumer ID here is actually acting on 2 partitions, versus the other ones only have 1 partition assigned. And what this tells us is that we're basically having a capacity allocation problem. Our consumer group is handling twice as much load as all the other ones. And so we need to actually make sure that we add like at least 1 consumer group to this application, or figure out some way that we can rebalance the partitions across the consumer groups a little bit better. So that's the first thing you want to look at. And the next one is you also want to watch out for some partition skew. In this case, one easy way to look at that is just to look at the log n offset in the same output. And what we can see here is that we roughly have the same number of messages in each partitions. That means our partitions are fairly well balanced. We have the same number of messages. But if that's not the case, we need to actually look a bit more in detail and watch out for this. And why is this important is because if you're using key topics, or if you're using custom partition topics, now suddenly you're not distributing randomly messages to any given partition. You're actually sending them to a very specific one. And based on your data, let's say you're doing a group by operation in your stream application, you will typically send the data for each group into one partition. And if your data has like a certain skew, you will end up with a lot of skew across all your partitions. And some of the warning signs you'll notice, like you'll see like only some of the partitions lagging. You'll see very uneven CPU and network usage across your consumers. And some of the other causes for that is if you're doing a stream join, for instance. It's a typical example of someone will do a join of 2 topics, and it turns out one topic has 90% of the keys are nulls, and you're basically joining on nulls, and all of that goes to one partition, and that one partition will never be able to catch up because it's just too much to handle. So in that case, you will want to filter out those messages first because they probably aren't really valuable for your join, or you can handle them separately. The last thing you want to look at, really, once you've like kind of rolled out all these other cases, is looking at imbalance across brokers. Let's say you just started with like 1 broker or 2 brokers, and then you added 3 more. Then none of your partitions are actually going to rebalance to the other brokers. They're all going to be sitting on the first 2 ones. Only the new topics created will be on all the brokers. So in that case, you want to be able to like figure out like how can I actually rebalance my partitions across all the brokers so that I have even throughput and use them all evenly. And partition lag will also give you some of that information once you've kind of rolled out all the other cases. The next thing you want to look at, if you're still having problems once you kind of rolled out any kind of skew or weirdness on the partition side, is to look at the clients themselves. A lot of people don't know that the clients actually have metrics as well. And I know it's not as common to kind of grab metrics from a third-party library inside of your application, but that's something that you should be doing. And the reason for that is that GC, CPU network, all while being important, they're not going to tell you everything. They're not going to tell you, is my problem on the producer side, or is it on the consumer side, or is it in my application itself? So the clients have metrics. They break it down by consumer and producer. The first thing you want to kind of look at is the global request latencies, which are broken down by consumer and producer. And that will kind of tell you, well, is the problem on the consumption side, or is it on the production side? So that's the first thing. If you still not really have any idea of what you want to do, or if you can't really tell anything special on either side, then you might want to start looking deeper and kind of break it down. So those metrics are actually broken down both by broker and by topic. And you want to look at the broker metrics because that will tell you if there's a single broker that's having an issue. So if all the consumers are reading from that same broker, like the global metrics will not tell you if there's a problem because they all have the same issues. But if you break it down by broker, you can now tell, like, oh, I have one broker which is having issues, whether it's I/O or network or something is going on. And then on the topic side, if you're consuming multiple topics in your application, the breakdown by topic will help you identify if there's any particular topic that's causing problems, and maybe you need to do some data tuning or data adjustments or tuning on the actual topic settings or client side to get that working. The next thing you want to look at is the log levels. So the typical answer we get from people is that the logs are very verbose, and so they haven't turned them on. And then in cases where they do turn them on, they're like, well, we don't have them anymore because they took too much space, so we removed them. It is very important to look at, especially the consumer logs. You want to set them to debug if you're having any kind of issues. On the producer side, the producer tends to be very, is not very verbose. So there you want to sometimes even go up to trace to really identify some tricky problems. But you need to really crank up that level because by default, people often leave it to just error. And in that case, that doesn't tell you anything what would happen. It tells you what the problem was, but it doesn't tell you why it happened. So let's say you don't have any metrics at all, any logs at all. What do you do? Well, there's something you can do. We can do some profiling. I know there was a talk yesterday about async profile, if any of you saw it. It's kind of similar to the same tools. So you want to install your flame graph tools, your JVM profiling tools, and if you want to impress your coworkers, there's this cool tool called FlameScope from Netflix, which does all that and has a cool web UI. You can kind of drill down. So as long as you have this special flag set on your JVM, you'll be able to get so much more information out of your system in production. And it doesn't really affect performance that much. I mean, the impact is roughly around 3% in practice. And what this is going to tell you, once you have those tools available, you can actually drill down into your application without having any logs or metrics at all. You can actually see what's going on. And so what this chart is kind of telling you, and this is actually from an application we run in-house, like a Kafka Streams application. And it tells you kind of where your CPU cycles went. It doesn't tell you if there's something else blocked, but at least you can see where your CPU cycles went. On the x-axis, you see how much, the percent of CPU time that was spent, and on the y-axis is kind of the stack. I mean, this chart is actually interactive, so you can actually drill down into each of these pieces and kind of expand them and see look at individual pieces and see what it is. I'm just going to kind of go to the high level and kind of show you because I don't have the interactive version here. But the yellow part here you're seeing this is all the time we're spending in GC. So we're basically spending 20% of the time roughly just doing GC. And you can see that immediately from that. You don't even need to look at your logs. It's very powerful for that. So that what tells us we probably have tons of small objects being garbage collected all the time, maybe some serialization or deserialization problem. That's typically what we see in Kafka. Next, we have RocksDB. So this is all this native code that's running, that's being called by the JVM and some background threads. This is this Kafka Streams app, so it uses RocksDB under the hood. In this case, we're actually spending a lot of time doing stuff in RocksDB. So I would say roughly half the time is actually spent getting, scanning. Maybe we need to do some optimizations in our Streams app and how we use the state stores, or maybe there's some bug in Kafka Streams in this case where it was doing things that were kind of unnecessary. You can identify a lot of problems like that. This was a Kafka pull loop, so this is actually the time you spend just getting data out and deserializing it and reading it. So you can say, well, we're actually spending quite a bit of time doing that. It's probably a deserialization problem, which kind of goes back to the GC problem we saw earlier. And lastly, once you drill down, you can look at your actual classes and see where your code is running. Well, this is actually just time you spend in your actual code. So we're only spending maybe like 30% or even less, 20% of the time doing actual work, business logic, actual application work. The rest is just like Kafka, garbage collection, and Kafka streams. And you don't have very much control over that unless you're actually doing something really wonky with the clients themselves. And if you decided that identified it is still not anything, then maybe it's your code that's the problem. And I'm going to talk a bit more about like some of the classic mistakes that people do when they first start writing a Kafka application. On the client side, people will be like, oh, like I'll just commit every time I get a message. I'll just commit just to be safe, right? Because they don't really have a concept of like what it means to do a commit. They're like, well, I'll commit just to make sure. Like it's something I need to do anyway, so I might as well do it on every message. And that's actually a really bad thing to do because a commit is actually very expensive to do. It has to go round trip to Kafka, write to the consumer offsets topic, and then send back. And so you're basically like stalling your consumption every single time you do a commit. You don't actually need to do a commit with every single message. You should actually do this in a more asynchronous fashion or in a more in a manner where you're actually consuming more, like a couple hundred messages or even more before you actually do a commit. You want to keep your times between commits short enough that you don't have to worry about recovery time, because you're just going to start back up from where you did your last commit. So as long as you commit often enough, that won't be a problem. But you also want to commit infrequently enough that you actually maximize your throughput. So you should kind of find the right trade-offs here for your application. What kind of recovery time do I expect, and how do I want to maximize the throughput, and only commit as often. And the kind of metrics you can see on the client side, the commit rate and the commit latency will kind of tell you how often you're doing this and if there's any issues around that particular aspect. The other thing is to right-size your batches. So that's on the producer side. Gwen will probably talk a little bit more about that in a little bit. But
I was planning to say that you will talk more. You already talked more about it, so I can keep it short.
All right, so you want to have bigger batches. Bigger batches increase your throughput, they increase your compression, because the compression is done at the batch level. And you still want to keep them, but you still want to keep them small enough so we don't exacerbate the GC. So your messages should not ever exceed like 10 megabytes ever. I mean, that's really like the maximum we recommend. Even by default, I think we recommend we have 1 megabyte maximum. But in order to get the batches, it's not actually enough to send the batch size. You think that's enough, but that's not the case. Because unless you're actually producing really, really fast, the producer will not wait for the batch size to be to reach the batch size to actually send the batch. It will only wait for linear milliseconds, which by default is 0. So you need to actually set it to be like, let's say, 50 or 100 milliseconds, just long enough for enough messages to accumulate in the buffer so they can actually create a batch out of it. And that's something that people often forget, and so they don't get any batching even though they set the batch size. The thing you want to watch out here is like you can look at the request rate and the request latency, and that's kind of going to tell you like, am I actually doing batches? If you have a very high rate, that probably means you're not batching enough. And your request latency, if it's very high, probably means you have like too big of a batch or something. On the compression rate, you can actually track the compression rate on the producer side as well, and that will tell you, am I reaching like the sweet spot around like batch size and compression, and that will maximize my throughput without completely causing GC issues. The last topic I'm going to touch on is the concept of rebalancing. So applications like the Kafka application will sometimes get into the state where it starts rebalancing forever. And the symptoms you'll notice is like basically the app is doing a lot of things. There's a lot of network chatter, lots of logs, but it's not actually making any progress or just hanging there. So how do we identify that? So just to kind of recap on how balancing works. So the purpose of balancing is really to distribute the load of the application across all the different consumers. And so we have to somehow assign the partitions to individual consumers. So each consumer group basically may start out with let's say we start with 2 consumers consuming those 6 partitions. If now we add another consumer to the group, it now needs to send a message to Kafka and be like, hey, I want to join the group. Give me some partitions. So what happens at that point that we basically stop all the production and the consumption. There's no more messages going through the consumers. The other consumers now have to send another join group request again, at which point the broker will respond and say like, okay, well, here's a list of consumers that I have, and it will also elect the leader and say like, hey, consumer B, you're in charge of actually deciding who gets to work on what. And doing this client side actually is helpful because then you can customize it in your application, how you distribute across your consumers. Then you have to send a sync group request, which also includes their assignment from the consumer that the consumer B decided on, and then it sends it back to the consumers and be like, okay, now you're actually charged in those partitions, and now we can finally go back and consuming from those partitions. And you can imagine like there's a lot of steps involved here. So if you have consumers coming and going out of your application all the time, that's going to cause a lot of network chatter. There's a lot of things going on. So how do we kind of restore a happy balance here? So what you want to watch out for is like those long GC pauses. So similar to how on the Kafka broker side, if you have long GC pauses, then we'll think that the consumer dropped out of the group, and so we'll cause rebalancing. If you're not calling poll enough, let's say you have very infrequent data, and you say, like, oh, I'll just call poll every like 10 minutes or every 15 minutes. That's not enough, because if you don't call it at least every 5 minutes, by default, your app is going to, the client is going to think, oh, maybe like this app is stuck. I'm just going to leave the consumer group because there's a problem in the application. So you need to actually call it often enough to make sure that you keep the clients happy. And the other thing to watch out is for any like timeouts that might be too short. If you have like flaky network, let's say you're in AWS, I mean, it's pretty common to have kind of network problems, and a lot of the timeouts that are the defaults in a lot of libraries and applications are typically set for data center usage, not for cloud usage. So you probably want to increase some of your Zookeeper timeouts and other things like that. At least on the broker side, the clients don't have a Zookeeper, but they have the clients have other things like request timeouts and things like that you want to watch out for. And just to say, like, one bad machine can affect the entire group, so you want to watch out that you don't have the situation where you have one machine that just like keeps like flapping and causes everything to constantly rebalance. And the way you can track that in your metrics, we have the join rate and the sync rate. The join rate basically tells you every time we send a join group request, the sync rate, the sync group request. And if you see a lot of very high like rates at this point, that probably means you have a problem in your client side and something is causing the rebalancing. You want to start digging it a bit deeper. So just to recap, so the component users, they will monitor consumer lag, like I said, the first thing to look out for. They'll look for partition skew. They'll commit offsets sparingly and collect the logs, understand how to tune their batch sizes. But the real pros will also want to understand what's their partition assignment, how do I actually do some good capacity allocation. They actually start monitoring their clients. They understand the concept of rebalancing. They understand some of the protocol. And they know how to profile the applications. And the end goal is really to be able to tell, like, is this problem in my client, is it in the app, or is it in the broker? And with that, I'll leave it to Gwen to talk a bit about replication.
So when we talked about how to demonstrate all those client problems, we were like, let's come up with the simplest possible Kafka application we can think of and show you just how everything comes into play with this really, really simple application that has no logic. What is a simple Kafka application that has zero logic in it? It's a replicator, or in Kafka open source mirror maker. It's a consumer that consumes from one Kafka cluster, does absolutely nothing, and writes to another Kafka cluster. So it should be very, very easy, and we should see zero performance problems, right? Because our code, we know, is doing absolutely nothing. It's all client to client, and we have zero logic. But it turned out that there's still some stuff to be mindful of. So performance, and especially being really up to date, is super important when you replicate cluster to cluster, because the main use case is DR, right? That's the main reason people copy stuff from one cluster to another. And a DR that is too far behind is worse than useless to the business, because during a disaster, if you fail over, you basically lost data. So what happens is that, imagine 3 AM, something terrible just happened to your Kafka cluster, maybe this upgrade from a few slides ago. And your manager says, we gave up on trying to fix it. We keep running into those GC issues. We cannot really debug it. Can we just fail over to secondary? And remember that we are not allowed to lose more than 7 seconds of data. So he asks you, is the secondary cluster more than 7 seconds behind? Yes or no? And can you, at 3 AM, answer this question? Is this information you have? So this is the first thing you want to monitor when you're copying data around. Did I catch up to date? In the terminology of what we just talked about on the clients, this is the consumer lag. How far behind is the replication process behind the latest data in the main cluster? So you really want to watch. This is a different way to look at the command line output that Xavier shared earlier. You want to watch out for which partitions are behind, how far behind. Consumer lag, as Xavier already showed you, it talks about the number of messages. So you can go to your manager and say, I don't know about 7 seconds, but we are 15,000 messages behind. And if you really, really know your system, you can say, OK, we normally get 100,000 messages per second, so 15,000 messages is clearly less than 1 second. We're good to go. We are fine. But if you have very spiky kind of production issue, you cannot really know how far behind are you. So this is kind of good, and it's very easy and very cheap to get, but it doesn't always answer the business questions that are mostly around time. So we also recommend monitoring lag. This is control center again, monitoring lag in the number of seconds. And you do it basically by taking a timestamp on every produced message, and then when the consumer consumes messages, it checks the timestamp, and like it knows right now it's 3 p.m. I'm seeing a message that was, it says it was produced at 2 p.m., and as long as you manage to synchronize the clocks, you can have your consumer basically tell you how far behind it is. So if you need this kind of timing, it's very useful at times. So here's what our replicator looks like when you kind of dig into the details. It's very simplified, but the idea is that you have the original Kafka, you consume events. The consumer has a consumer buffer. We talked about the batches a second ago. We write to the producer, and when we do the producer does the send, it basically blocks when the buffer is full. So if you have too many messages in the process that we cannot send for any reason, we basically stop. And then we write the data to destination. We get an acknowledgement, hey, the data was written to the destination Kafka, and then we go back and commit. We try really hard not to lose anything that is in flight. But this also means that it makes it really hard to know which part is slower. Because if you see that, hey, we're not making any progress, consumer is lagging, I can't just say consumer is lagging, therefore the consumer is at fault, because the consumer will block and stop consuming if the producer is failing to send. So if the producer is really slow, we will stop consuming and we'll see a consumer lag. So it's one system tied together, and our main goal is to break it apart. And we're going to use all the metrics that Xavier just mentioned to do it. So we started by looking at the producer side. It has metrics for I/O ratio, I/O wait ratio, and outgoing byte rates. Basically, you want to check if it's writing as fast as the network allows, and if it's busy. I/O ratio tells you how much time it spends actually sending stuff over the network. I/O wait is the time it spends waiting around for data to show up from the consumer. If you see very high I/O wait ratio, it means we're not doing anything, and you cannot blame the producer, it's just waiting. Very high I/O ratio, the producer is writing as fast as it possibly can, and we need to understand if that's fast enough, and if not, start adding more processes. Batch size, again, we talked about how it's important to maximize the batches. If you see that the maximum and average batch size that you see in the metrics are very close to the maximum batch size that you configured, it means that we're maxing out every batch, meaning we're sending as fast as we possibly could. We can try configuring larger batches and see if that will enable us to increase the throughput. And then if we're doing a lot of retries, we're seeing a lot of errors, something is very wrong with the Kafka over there, we need to fix it, and that explains everything, right? If every write fails, you're not going to make that much progress. They will wait with the photos until I get to the end, and then we'll see everything in one big slide. And then if you see, how do I know if the buffer is full, and I'm waiting because the buffer is full? I'm seeing a bunch of threads waiting, I'm seeing buffer full wait time going through the roof. That means that the producer is basically blocking the consumer. So now we know who to blame. If it's not the producer, well, we eliminated one, we're left with the consumer. Again, it will tell us how busy it is. Listen to it. If it tells you I'm reading out of Kafka as fast as I possibly can, it's time to tune what the network throughput could be. If it's kind of waiting around, maybe Kafka doesn't have that much data. Maybe that's the problem. The other, you want to look, again, there is another buffer, you have batches. You want to make sure that the batches you're reading from Kafka are large enough and that you you're waiting reasonable amount of time, but not so long that your manager will be upset. So check that the maximum fetch size If it's too close to the configured possible maximum, maybe you want to grow the configured possible maximum and try to read bigger batches. And if you do a lot of fetches, maybe try to make bigger batches. Fewer fetches may allow you to maximize the throughput on the pipeline. And then obviously record max lag is the thing you want to watch out for. And now is the right time to take a photo. Everything goes up. Get my good side, yes? No, I'm kidding. You take a photo of the slide. OK, so this is kind of like, you can see how you have a lot of metrics, and you collect them together, and you can build a picture of in your mind of what the system is like, what it's doing, and where the problem is. Like there is a bottleneck somewhere. We're looking for it. And then this also tells you what to fix. So I kind of talked through it. I said it could be a network or Kafka performance issue if you see the producer is not sending fast. It's trying to send as fast as it can, but it's not enough. You can try to increase the batch sizes to get better throughput. And again, if you see a lot of errors, then Kafka may be having an issue. And the other side, the same thing. If you have slow fetches, it could be an issue with the original Kafka. It could be that you need larger batches, or just to wait more time for the batch to fill, or the reverse. Wait a bit less, and the system will just go faster. If you're waiting too long, then you'll be a bit behind. And then I already mentioned that other than tuning the consumer and producer and fixing your Kafka, you may want to do some network tuning, especially if the distances are large. Linux defaults are not very good, and Kafka defaults are not very good for end-to-end network tuning. What you really want is to understand that Kafka has network parameters, and the clients will have network parameters, and your operating system at all sides. The consumer, the producer, the original Kafka, the end Kafka, all of them will have those network configurations. If you take a machine, for example, the destination client, and you tune it to the hilt, but you don't tune the brokers that it's reading from over the one, then it's not going to do anything, basically. So make sure that you tune Kafka, and you have those send buffer bytes and receive buffer bytes, and you tune the operating system, net core RMM default. Again, there's a nice paper on how to tune network for the one. I don't have to teach it all from scratch. And then you want to enable the network selector or debug rate to check if it had any effect. And then stop running it in debugger because it uses a lot of I/O and you don't really want it. But make sure it's very easy to just change one parameter and wondering, oh, it didn't do anything, this thing is just crap. So make sure that what you did had an effect. So good users monitor consumer lag. They add processes when things are slow. Scale out is always an option. And they automate it. So they click a button and they can add more producers and consumers. If you're a pro, you also monitor the time lag. You have all the client's metrics, so you know if the consumer or producer has to play them. You know about the configs. And you know how to tune the network over the one because you read all those different papers that I pointed out. That's about it. You can read more about our blog. You can download the demos that will kind of allow you to play around with our monitoring tools and the platform. And we have an amazing Slack community, 4,000 people from all over the world answering questions about Kafka all times, night and day. And some of them are brilliant. And if you were like, hey, my Kafka is slow and I actually don't have support, this is a very good place to kind of think with other people and get some advice and not shoot yourself in the foot.
All right, thank you so much, guys.
And we'll be at the Confluent booth. We can also answer questions, and I'm signing books, and it will be fun.